Hello students, in this video we will discuss about dielectrics and its property. First point is dielectrics. What is dielectrics? Dielectric is a substance that does not allow the charge to flow inside. This is a dielectric material which does not allow the flow of charge inside it. This is the definition of insulator, but this contains the charges. This substance contains the charges that can be polarized and that cannot be that may be polarized and they may not be polarized, but it will rotate about its position. Okay. Like glass, wax, air, etc. Next point, behavior of conductor and dielectric in the presence of an external field. When we place a conductor in an external field and when we place a dielectric in an external field, what will happen? If we place a conducting material in a external field, this is a plate and external field is in this direction. If this is conductor, this will induce negative charge here and positive charge here. Induced electric field will be opposite to the external field, that is E0. In the presence of case of conductor, E0 means external field is equals to induced field, that means E net equals to 0, means inside the conductor electric field is 0. Now if we place a dielectric substance, this is the wax or glass dielectric substance, external field is E0 and induced field is, let us suppose, I and D. External electric field is always greater than induced. That means there exists an electric field inside dielectric materials. Okay, this is the behavior. Electric field inside the dielectric material will present, and this will be less than the external field. And in the case of conductor, there is no electric field inside the conductor because external electric field and induced electric field is equal. That means net electric field will be 0. Next point, polar molecules. What is the definition? When the center of mass of positive charge does not coincide with the center of mass of negative charge. If the center of mass of positive charge does not coincide with the negative charge, center of mass of the negative charge, that is polar molecule. If coincide, that is non-polar, like H2, for example. Non-polar molecule and polar molecule. Polar molecule is HCl. This is partial negative and this is partial positive. Positive charge, center of mass of positive charge is here and center of mass of negative charge is here. This does not coincide, that is polar molecule. Or in the case of non-polar molecule, H2. Center of mass of positive and negative both are at the same position. That means we can say that center of mass of positive charge and center of mass of negative charge coincide, that is non-polar molecules. Next point, dielectric strength. When a dielectric material is placed inside an external field, maximum external field within which the material, the dielectric material behaves like dielectric material, means maximum external field that can be applied to a dielectric material before it breaks. That is the dielectric strength. Next point is capacitor with dielectric slab. Capacitor with dielectric slab, and then capacitor with conducting slab. When we place a dielectric material in between the plates of the capacitor, what will happen? This is a calculation derivation. Let us suppose this is the positive charge and this is the negative charge. This is a capacitor, and distance between these two plates is d, and area of the plates is a. And let us suppose we fill a dielectric material in between the plates, and the thickness of this material is d. Total distance between the plates is d, and the thickness of the dielectric material is t. Total potential will be V is equals to we can write total potential V is equals to V naught plus V dash, where V naught is the potential due to this plate and V dash is the potential through the dielectric substance. We can write V is equals to E is equals to V upon D. We all know. In place of V we can write E into D. मतलब यहाँ पे क्या हो गया, इलेक्ट्रिक फील्ड into distance between the plates. Electric field E naught into V due to plates. Now there is the distance between these two places D, but this thickness is omitted. That means the air will be in this thickness and in this thickness. The total space between these two plates within which the air is present, that is D minus T plus dielectric slab, that will be equals to E into T. E is the external electric field due to these plates, and E is the net electric field in the dielectric. That is not E naught. Okay. Next line is E naught into D minus T plus, we know that E naught upon E is equals to K, where K is the dielectric constant. In place of E we can write E naught upon K is equals to E. In place of E we can write E naught upon K times T. We can take common E naught, D minus T plus T upon K. Again we can write E naught. E naught is the electric field of the plates, that is equals to sigma upon epsilon naught D minus T plus T upon K. Sigma can be written, sigma is the surface charge density, and surface charge density is Q upon area. We can write Q upon epsilon naught A. Q upon A is the sigma, D minus T plus T upon K is equals to V. And we all know that C is equals to Q upon V. If we need to calculate capacitance, there should be Q upon V. Q upon V. If we rearrange Q upon V, this particular thing will be there. This is in the numerator. Here will be in numerator. This is in denominator. There will be in the numerator. and this is in the numerator, there will be in denominator. Q upon V will be equals to epsilon naught A upon D minus T plus T upon K, and Q upon V is C, means capacitance of the parallel plate capacitor. Capacitance of the parallel plate capacitor when a dielectric slab is inserted between the plates, the capacitance of the parallel plate capacitor will become epsilon naught A upon D minus T plus T upon K. There is special cases. Uh, if we take T equals to 0 in first. T equals to 0, that means no dielectric slab is present. T equals to 0 means no dielectric slab is present. C will be equals to epsilon naught A 0 upon something, 0 and 0, epsilon naught A upon D. We can write C as C naught. There is no material, no dielectric slab between the plates, that can be written as C naught epsilon naught A upon D. Second point, if T equals to D, what it means? It means that the thickness is equals to distance between the plates, or in the other word we can say that the plate, the capacitor is completely filled with a dielectric material. What will happen? The formula will be C is equals to epsilon naught A upon D minus D plus D upon K. D cancel out. Epsilon naught A upon D upon K. K ऊपर चला जाएगा, क्या हो जाएगा यहाँ पे? K times epsilon naught A upon D, means when the capacitor is completely filled with a dielectric, the capacitance of the parallel plate capacitor will become K times epsilon naught A upon D, or in other word we can write C is equals to K times epsilon naught A upon D. Epsilon naught A upon D can be written as C naught. C naught is constant, means C is directly proportional to K. If we insert a dielectric slab between the plates, the capacitance of the parallel plate capacitor will increase. Okay. Next point and last point is when capacitor with conducting slab. When we place a conducting slab in place of dielectrics, what will happen? Okay. If this is a conducting plate, the electric field inside the conducting plate is 0. We can write V is equals to V naught plus V dash. V naught in place of V naught E naught into D minus T, like in previous question. E into T, there exists an external electric field. But there is no electric field inside the conducting slab. That means this will be equals to 0. Finally, we can write V is equals to V naught. And V naught is equals to E naught D minus T. We can write sigma upon epsilon naught D minus T. This can be written as Q upon epsilon naught A D minus T V. We can rearrange Q upon V, that is equals to C, and that will be equals to epsilon naught A upon D minus T. That means if we multiply epsilon naught A upon D into D upon D minus T, multiply by D and divide by D. This will be equals to C is equals to C naught, C is equals to C naught times D upon D minus T. This, if thickness is present, means there exists a T, the denominator value will be less and numerator will be greater. That means capacitance will increase. If we insert a conducting slab between the plates, the capacitance will also increase. Now the next point is effect of dielectric when the battery is kept connected. Effect of dielectric when the battery is kept disconnected, and next point is remains connected. Seventh point is effect of dielectric when the battery is disconnected. When the capacitor is disconnected with the battery, means there is no path or circuit is open, charge cannot flow through the capacitor. And when, what will happen when the dielectric slab is inserted between the plates of the capacitors? First point is charge. What will happen with the charge? Charge will remains constant because there is no path for the charge to flow from the battery to the capacitor. That means charge will remain constant. Next point is potential. What will happen with the potential? Potential V is equals to Q upon C. We know that Q is equals to C into V. V is equals to Q upon C. Charge is constant, that means Q is equals to Q naught, final charge is equals to initial charge, and K, in place of C we can write K times C naught, and in place of Q naught we can write C naught V naught upon K C naught. C naught cancel out, V naught upon K. Finally we can write V is equals to V naught upon K, or we can write V is inversely proportional to K. Potential will decrease when we increase the value of dielectric constant or K. What will happen with the capacitance of the capacitor? C is equals to Q upon V. Q equals to CV. C is equals to Q upon V. Q remains constant Q, and in place of V we can write V naught upon K. K times Q naught upon V naught. We can write K times C naught. Finally we can write C is equals to K times C naught, or we can write C is directly proportional to K. On increasing the value of dielectric constant K, capacitance of the capacitor will increase. Next point is energy. What will happen with the energy when we insert a dielectric slab between the capacitor when the capacitor is disconnected from the battery? Formula of energy is U is equals to 1 by 2 CV square 1 by 2 C. C can be written as K times C naught, and V can be written as V naught upon K whole square. 1 by 2 K C naught V naught square upon K square. 1 by 2 C naught V naught square into K upon K square, that will be 1 upon K, and this whole thing will be equals to U naught initial energy. Final energy is equals to initial energy into 1 upon K. Finally we can write U is inversely proportional to K, means energy of the capacitor will decrease if we increase the value of K. Okay. Next point, that is last point in this chapter, that is effect of dielectric when the battery remains connected. Effect of dielectric when the battery remains connected means we need to discuss the potential, effect of potential when the batteries remains connected. Means there is a path from where the charge can flow to the capacitor. First point is potential. Potential remains constant because battery will continue battery will continue its potential constant because this is the property of the battery to remains its potential across its plate. If the potential across the battery is constant, means this is directly connected with the plates of the capacitor. That means the potential across the capacitor will also remains constant. First point is potential, that is constant. Next point is electric field. Electric field is V upon D. We know that in this particular case potential is constant V naught upon D. We can write V naught upon D as E naught. Initial electric field and final electric field is constant. That means electric field remains constant. When we talk about charge, Q is equals to C into V. What will happen? Potential remains constant. C is equals to K times C naught. V is equals to V naught. Because initial and final potential is same, we can write V is equals to V naught. We can write K equals to C naught V naught. That is Q naught. Q is equals to K Q naught, or finally we can write Q is directly proportional to K. On increasing the value of K, charge on the capacitor will increase. Next point is capacitance. What will happen with the capacitance? Capacitance. C is equals to Q upon V. Q is equals to K times Q naught and V is equals to V naught. We can write C is equals to K times Q naught upon V naught. Q naught upon V naught equals to C naught. We can write C, capacitance, is directly proportional to K. On increasing the value of K, capacitance of the capacitor will also increase. Next point and last point of the chapter is what will happen with the energy when we insert a dielectric slab between the plates of the capacitor when the capacitor is connected with a battery. Energy U is equals to half C V square 1 by 2 C. We can write K C naught. In place of V we can write V naught. 1 by 2 C naught V naught square times K. In place of this we can write U is equals to U naught. In place of half C naught V naught square we can write U naught times K. Energy is directly proportional to K. Means we can say that on increasing the value of K, value of dielectric constant, the energy of the capacitor will increase. Okay, thank you.